I'm here with Assistant Professor of Computer Science Nilanjan Banerjee of the University of Maryland at Baltimore County and Senior Research Program Manager Arjmand Samuel of Microsoft Research. They're going to tell us about some exciting research into improving the quality of life for paralysis patients. Thanks for being here, guys. Appreciate it. This is going to be fun. We'll start with you, Nilanjan. You're a professor of computer science. You're not a medical doctor or a physical therapist. So we're sort of wondering how you came to be involved in working with paralysis.
So it all started with the usability study that we did at Madonna Rehabilitation Hospital in Nebraska. So I have a collaborator there who is actually a medical doctor.
Okay.
So in that usability study, we were trying to figure out what are the limitations of assistive care devices. And what we found was most of the devices that people use nowadays, especially people with paralysis, for environmental control is very bulky as well as very expensive. So we thought we need to do something about this problem. So we worked with these doctors at Madonna, trying to actually build systems which can be embedded into your items of daily use.
Okay.
This could be like clothing, this could be bed sheets, pillow covers, and so on and so forth. And it can detect gestures for people with paralyses for environmental control.
Okay, so let's dive deeper into that. So as a computer scientist, how are you working to improve the quality of life for these patients?
So I'm basically building sensors in collaboration with Microsoft Research, which can detect very subtle gestures of patients suffering with paralysis. So they can use these sensors for controlling appliances, making a nurse call, or even making a 911 call. So, and the systems that I'm building would be kind of invisible from the patients, so embedded in surroundings around them, and they would kind of work seamlessly with minimal intrusiveness.
So is this similar to when quadriplegics used, the head sticks or the lasers to control switches or keyboards?
It is similar, but it's much less intrusive.
Right.
So essentially, these sensors are kind of invisible from the patient. So and does the same task as laser-mounted headgears.
So obviously this work must be, difficult but incredibly rewarding. Talk about some of the things you've already witnessed happening here.
Right. So one of our team members is actually a patient who suffers from paralysis. His name is Buzz, and he has been using our system and providing us feedback on how the system could be improved for better usability of patients of that group. So I think the biggest reward for us here is when Buzz actually uses the system to control his appliances at home.
We're seeing him do it here. So just swiping his arm over his knee was actually activating?
Yes.
Anything from what? TVs to appliances to lights?
Yeah, in that particular demonstration, he was actually activating a lamp.
Wow. And so talk about how that, it's obviously not just as simple as that. How do things like facial gestures and waving of the arm translate into activating something that's across the room or maybe across the house?
Right. So essentially our sensors are capacitive sensors. So they act as proximity sensors, but they can be built into clothing. So what these proximity sensors do is...
And you've got one in front of you here.
That's correct. So this is one preliminary prototype that we have developed, and the sensors are actually embedded inside the jeans fabric or the denim fabric. And the idea here is to use these sensors as proximity sensors. So anybody waving their hand on top of these sensors would be detected as a gesture. And over a Bluetooth connection to a computer, it can be used for controlling different appliances in the home.
So that's how the data is processed and then it's sent on to the things that are being controlled.
That's correct.
Wow, that's fascinating. This is a good opportunity to bring you into the conversation, Arjmand. Walk us through the components of the Lab of Things and sort of explain how they facilitate research, like what's happening with Nilanjan.
Right. So the Lab of Things is a research platform for the Internet of Things. Now, the vision of the Internet of Things is that the common things around us would become smarter. And as we like to call it, ambient computing would be all around us. So things would just be smarter and they would be thinking. So if a researcher like Nilanjan would be developing such sensors or things, the Lab of Things makes it easier for them to deploy and to do research in that space. Now, of course, the Lab of Things opens up this research opportunity for the Internet of Things. And we are just starting to see some of the cool scenarios that can be enabled by this.
Yeah.
And this one is certainly one of those.
And as you mentioned, Nilanjan's work isn't isn't the only current research that is using Lab of Things. I understand it's also being used to study electrical usage in homes. What can you tell us about some of that research?
Right. So since Lab of Things is really a platform which really brings down the barrier to research in this new space, we are seeing Lab of Things today being used in energy management is one domain, research domain, where people are looking at how to optimize place energy usage in places, in countries where there is less energy. That's one. Then we are also looking at its applications in healthcare. This one sensor is one, but more so in other parts of healthcare, like in-place aging. When people age at home, we want to augment their environments with technology.
Yeah, talk about that. That's
So,
very
increasingly, we are seeing that, of course, people are getting older, they live
Right.
longer, and they want to live at home.
Sure.
Comparatively healthier lives where they can move around, but still, we would want, and their caregivers would want to know how they're living, and would want constant feedback, and would want to know if they fall while sleeping, or so. All of those things can be detected with sensors. But of course, we have to figure out what are the right kinds of sensors to put in these environments, and also what are the issues of privacy, security, reliability that need to be built into these infrastructures.
Right.
And all of that is only possible if we do some research into that space and try to figure out what are the right system design. So the Lab of Things enables all of that. So it is a platform, it's an open platform which allows people to exercise their creativity in different research domains.
Are there any other ongoing Lab of Things projects that you can tell us about?
Yeah, there are quite a few of those. So, of course, this is one. Then we have one in Pakistan where they're looking at energy use in that country because chronically there is a shortage of power, electrical power there. And they want to optimize how power is to be used in a home and how they can switch on and off different appliances. Then we have people who are looking at Lab of Things and connecting it to the Connect sensor and trying to figure out if people suffering with Parkinson's disease, how are they doing when they walk in the morning? Are they getting better or worse? And to give their caregivers some kind of notice that this person is not feeling well. So that's another project that's happening at Purdue University right now. So we have quite a few of those projects, and our site has a more exhaustive list there.
Yeah. And obviously, you've got a lot of folks interested. Someone here in our online audience already sent in a question to you, Arjmand. Says, how do I get started using the Lab of Things platform?
lab-of-things.com. That's where you go to the site. We have downloadable source code. All of our source is there. You can download it and start playing with it. Now, another feature of the Lab of Things, which we started off earlier on, is that it's a community-based infrastructure. So while we, Microsoft Research, have provided this platform, but the drivers and the applications that run on the platform are being contributed by the community, by researchers like Nilanjan. And so if this person on the online would like to contribute code, Codeplex is the site where we host our code. They can then put it back into the repository, and then other researchers can use it from there. So it's truly a community-based infrastructure, which we would like the community researching in the Internet of Things domain to really use.
A pretty impressive community and a tremendous resource. This is fantastic news.
Yeah.
And we want to shift back to your work in particular, Nilanjan. What are the next steps for you and Lab of Things?
So this entire platform right now is built on top of Lab of Things. So one of the things I want to do with this particular sensor is to make it commercially available in the next 2 or 3 years. So some of the things that we are working on right now is miniaturizing this particular module.
Right.
So this is pretty big, and it's an initial prototype.
These days, it's considered big, right?
So we want to actually make it really, really small so that they can be embedded into your clothing and would be literally invisible from you. So that's one area that we are working hard on. I think the biggest reward for something like this would be if this is commercially available, people can buy it, and people like Buzz can actually use it to improve their standard of living.
Now, we've got a question for you from the online audience. It says, I recognize that motion sensors currently can detect when someone walks into a room. Wouldn't that be the way, an alternative way to turn on a light? And it says, can you elaborate on this and how it's more beneficial?
So this provides a much richer set of gestures than motion sensing.
Right.
So motion sensing, like in rooms, can detect whether you're going into the room or getting out of the room. But this can detect complex gestures. The swipe is just one gesture that we used for the demonstration out there. It can detect like writing alphabets. It can detect like a large set of gestures that could be used for appliance controls of different types. So the set of gestures is much richer. And also, since this is wearable, then potentially you take the sensor with you and can be used for control from anywhere, literally.
And so talk about the process of getting this technology, getting it to work, seeing it in action, and then, like you said, going back to the drawing board and saying, great, now we got to make it smaller. Everybody rethink everything we already did.
Right.
Is it frustrating? Is it inspiring? Is it all of the above?
No, it's actually very inspiring. So initially, when we started this project, we didn't really have any paralysis patient on our team, and we were just building systems which work. But once we have buzz on the team, we are getting like explicit feedback on what the sensor should look like, where we should place the sensors, what would be most comfortable, and so on and so forth. And we are like improving the product like almost every day now.
That's great.
So I think it's very rewarding to learn more from patients in that domain and tune your technology that would be useful for them.
Just about out of time here. One more question for you, Arjmand. What future areas of research do you see profiting from the use of Lab of Things?
So there's a lot of things that still can happen with the Lab of Things. We have hardly scratched the surface for this big new world of the Internet of Things. Privacy, security, reliability are three big ones that need to be really researched and understood before this becomes a reality. So in each of these domains, healthcare or energy management, all of these three, privacy, security, and reliability, have a role to play, and we need to understand that. So in terms of research, that is where a lot of time would be spent. Now, in terms of the infrastructure, we are constantly talking to collaborators, our academic collaborators, and trying to figure out what is that they want, what is that would help them be more productive in their research. So that is an ongoing thing, and we are constantly iterating on our design.
That's fascinating stuff. Nilanjan, Arjmand, truly, thank you. It's been a pleasure talking with you guys, learning about these rather exciting developments with Lab of Things. I'm betting our viewers would like to know about Lab of Things, of course. So here's a short video that explains more about this exciting new research platform. Let's see it.
The Lab of Things, by the very nature of this design of the platform, allows you to innovate quickly. It allows you to test out a design. It tests out your ideas very quickly in real environments, collect data, and then say if your design is working or not working, which is a very big motivation for innovation.
We are developing textile-based capacitive sensors that could be built into clothing, bed sheets, pillow covers, and even wheelchair pads. So the idea here is to use these sensors as proximity sensors to detect gestures for people with paralyses. So people with paralyses can use these gestures for controlling the environment, whether it's lights, switches, televisions, making a 911 call, or even making a nurse call. Lab of Things essentially provides the software framework on top of which we have built the data collection unit, data processing unit, and gesture detection unit.
My hope for this project is, with this technology, to have folks that have injuries such as quadriplegics or other types of impairments of their maybe upper extremities to be able to be more independent, to have the confidence that they don't have to rely on someone all the time. This way they can live their life as normal as possible and to be able to just get out, have fun, and enjoy life.
Lab of Things brings down the barriers of doing research with connected devices. It brings down the barriers by allowing people to deploy at scale and deploy in diverse geographies. And that is the power of the Lab of Things.